Hello and welcome to Machine Learning course. First, look at the picture. Did you observe the picture? Suppose a businessman and a farmer come to some bank for loan. Some loan manager simply offers share and cup of tea for businessman. But what for the farmer? Wait and come by queue. Loan manager does not check that this businessman eligible for loan or not. Normally, he is biased by businessman outfit and lavish lifestyle. Loan is approved for businessman and reject for farmer. Biased predictions made by the loan manager, thereby resulting in unfair biased decision. Present scenario is totally different. Which customer is eligible for loan, that is decided by machine or model. We'll discuss about this in artificial neural network. Train the model on credit score, balance, monthly income, assets, and type of service. Let's come to second picture. Observe this picture. Wife thrashing her husband with belna, meant a rolling pin. Wife yelling her husband. Our comments: this man has done something wrong. Come to this picture. Husband beating wife. Husband threatening and harassing wife. Normally our comments: this man should be behind jail. Gender study finds 90% of people are biased against women. Biased predictions made by the people, thereby resulting in unfair or biased decision. Bias and variance in machine learning. Bias and variance are two key sources of error in machine learning models that directly impact their performance and generalization ability. Bias in the machine learning model is about the model making prediction which tend to place certain privileged groups at the systematic advantage and certain unprivileged groups like farmer at the systematic disadvantage. Bias. Bias is the error that happens when a machine learning model is too simple and doesn't learn enough details from the data. Bias is the error that calculates the difference between the average prediction of our model and the actual value that we are trying to predict. Variance. Actually, variance is the opposite of bias. Variance is also an error that measures the randomness of the predicted values from the actual value. Variance is the measure of spread in data from its mean position. We will discuss later. Here, a model suffering from high bias. A model suffering from high bias is a simple model which pays very little attention to the training data. This type of model always leads to a high error on both training and test data. Let's take an example. Suppose we want our model to predict the cat and dog by showing photos of cats and dogs. We train the model on only one attribute, pointing ear. This one, the pointing ear. Same pointing ear for cat. Cat, dog. Dog, not pointing ear. Then we show the image one by one, like this one this one, and this one as a cat, and this one, this one, this one, this one, this one as a dog to the model. Now, show this picture and ask the model. This time, model predicted cat for pointed ear. Pointed ear. So, model predicted it's a cat. So, prediction value and actual value is same. Next, display this image to model. So, the model predicted it says cat because pointed ear. This shows the model is not able to capture other details when predicted as it has bias. Model suffering from high bias, model predicted it's as a cat also has pointed ears. So characteristics of a high bias model include not able to capture proper data trend over noise also, so giving a less accurate result, suffer from underfitting, a more general or simple model. A model suffering from high bias, that is underfitted, lack of an appropriate set of features may result in bias. In such a scenario, the model could be said to be underfitted. You can see this picture, underfitted. In other words, such model could be found to exhibit high bias and low variance. However, low variance can also indicate underfitting if the model is too simple and fail to capture the underlying patterns in the data. Underfitted models are like students who don't study enough, they don't do well in a practice test or real exam. Come to high variance. For a large volume of data of varied nature covering different scenarios, the bias problem could be resolved. However, the question has to be taken to avoid overfitting problem, meaning a high variance, which could impact the model performance in the sense that model would fail to generalize on all kinds of data set. Train our model with too much data or allow it to view the data too many times. It will learn the data including noise. In this case, our model is overfitted. Overfitting models are like students who memorize answers instead of understanding that topic. They do well in practice tests but struggle in real exam. Let's come to this picture. We want to classify the data into economical weaker section EWS. Those are income less than 8 lakhs per annum, and sound economical section more than 8 lakhs per annum. For a given set of training data, if the model creates a decision boundary such that every single data point is correctly classified, then it is called overfitting. You know, the problem with overfitting is that every single data point is taken too seriously by the model such that the decision boundary looks ridiculous, messy, and obviously incorrect. The model has no brain to think that some data points could be outlier and noisy and create a decision boundary for those points is wrong. Blue points, economical weaker section, EWS, and red point, sound economic section. you can see one blue point in red region, like a 7/4 in elite class. It's just like noisy. Also, one red point in the blue region, like some sound economical persons outlet or store is there. It's just like noisy or outlier. So we need to relax the model on that point. This is the Boole-Eyes diagram for bias and variance. Center circle. Center circle, you can see center circle represents a red circle, that is the truth sample. When your predicted value, purple circle, predicted value near to the inner circle mean truth, then it is called low bias. Bias is all about how close you are truth. If you are far away from the middle circle, then high bias. But both the cases, purple circle clustered together, it's called low variance. In high variance, they are scattered apart, but they are near to inner circle, mean red circle. Hence, they are low bias, high variance. Worst case scenario, there is high bias, high variance. Far away from the middle circle, that means they are high bias, and also individual predicted value, they are scattered value. Hence, they are high variance. Point should be noted. Splitting data into training and testing sets is not enough to prevent overfitting. Other techniques such as cross-validation and regularization are also used to prevent overfitting. You can see that is overfitting, and that is underfitting, and that is optimum. Our desired optimum. Some machine learning algorithms with a low bias are k-nearest neighbors, decision tree, and supervector machines. At the same time, some machine learning algorithms that have high bias are linear regression, logistic regression. Summary: bias, underfitting, high trend and test error; variance, overfitting, high test error. Come to upcoming video. Splitting into training and testing sets. Enjoy machine learning.